how to find out number of elements in a period. So there is a method to find out number of elements in a period. We know, we have studied in class 10 that in first period there are only 2 elements, then 8, then 8, then 18, 18, 32. How to justify that any period contains these many elements? So there is a rule for that. We have already studied how to write the electronic configuration and the sequence of filling the orbitals according to our Bohr principle, N plus L rule. We have already studied. So if we write the electronic configuration, if we consider the element in a period, the first thing is we should know that in a periodic table any period starts from NS and always ends at NP, means at the extreme left there is NS and at the extreme right it is NP of same value, means value of N on this side and this side will be same. Means if we are talking about second period, it will be starting from 2S and it will end at 2P. And in between that NS to NP, what are the orbitals being filled, that we have to write, and we have to count the maximum number of electrons filled in those orbitals. Let us take the example of fourth period. Fourth period, if we are talking about fourth period, then it means it will start at filling of electrons will start from 4S and will end at 4P. This 4P, all the orbitals will be completely filled. Here also all the orbitals will be completely filled, and this will together make elements of one period. So let us see what are the orbitals which are filled between 4S and 4P. Between 4S and 4P there is one more orbital, that is 3D orbital. And if we count the number of electrons, in S maximum number of electrons are 2, in D it is 10, and in P it is 6. If all the orbitals are completely filled, then one period will be completely filled, and each element corresponds to each electron corresponds to one element. We can very easily say that 2 elements plus 10 elements means 12, plus 6 is 18. So in case of fourth period, 18 elements are there. So like this we can justify how many elements will be there in a period. Let us talk about the second period. Second period, only 2S and 2P orbitals are there in second period, which will be filled. So 2S for 2 electrons and for P it is 6 electrons. So second period will contain only 8 elements. That is similarly for fifth period, it will start filling of fifth period will start from 5S and it will end at 5P. In between 5S and 5P, if we see that of Bohr principle, that line array of that filling of orbital, we can see that 4D will be filled before 5P. Now if all these orbitals are completely filled, it means fifth period will be completely filled. So let us count the number of elements. 2 electrons means 2 elements, 10 electrons in D it means 10 elements, and 6 electrons in P it means 6 elements. And if we add these numbers, we will get 8 electrons, which will correspond to 18 elements. That is why in fifth period maximum number of elements will be 18. It can accommodate only 18 elements. Similarly for 6S, it will start from 6S and in between and will end at 6P, and in between 6S and 6P filling of orbital 4F and 5D will also take place. And number of electrons in S is 2, 5 is 14, F is 14, D is 10 and P is 6. Let us add these numbers. We can see that there are 32 elements in this period. For seventh period, the filling of electrons will start from 7S and it will end at 7P, and starting from 7S till 7P, seventh period will be completed. And in between these two orbitals, these two more orbitals will be filled, and again like this we can add the number of electrons in these orbitals. 2 plus 14 plus 10 plus 6, it will make 32. So this is the way to justify that these many elements will be there in a period. Means that period will always start from ns, same value of ns, and will end at same value of np. And in between, what are the orbitals? You have to add those numbers, and that number will correspond to electrons as well as elements.